This is a second video on normal distribution. In this video, you will learn how to find area property in normal distribution. To calculate and apply z-score, finding the property of area in normal curve is often very important. For that, I have taken different dimension to plot the normal curve of area property. For that, let us consider an example. Here it is a basic problem which I have taken to make you understand how to plot and calculate area property in normal distribution. And here if the normal random variable x is normally distributed with mu 80 and standard deviation 5. To apply normal distribution, the data must be normally distributed. Unless it is a normally distributed or it is said so, we cannot go for normal distribution. This is a very important thing we should keep in our mind. And as I told you, there are two parameters in normal curve and normal distribution curve. One is mu and one more is standard deviation. In addition to that, the variability will lies on x, which means statistical mu. So we need to find out x is greater than 95, x is lesser than 72, x is in between 60.5 to 90, x between 85 to 97, x 64 to 76. All possible values for calculating plotting normal curve and calculating z-score I have considered in this problem. Now let us see how to plot this x value in the normal distribution. As I told you, this is a normal curve look like, and this 80 is a mu. Here it is our mean, population mean is 80 mu, and we are having 3 standard deviation to the right side and 3 standard deviation to the left side. Now if you plot x greater than 95, it falls here, 95 falls here. And one more thing we should keep in our mind, in the normal distribution mu is equal to 0, which means z-score here in the mu will be 0. So left to this side will be the negative value, right to this is the positive values. And consider here 72 will fall somewhere here, 72 here it will fall here. That is why lesser than a probability of x lesser than 72, which means 80 is a x and 72 is a lesser than 80, and again 80 is a x and probability 95 is greater than x, means this 95 is highest greater than 80, which falls in right side. And here third one, between 60.5 to 90, so 60.5 somewhere will fall here, and 90 it is 90. We have to look in between these 60.5 and 90, between this area. And in the fourth example, between 85 to 97, which means 85 here, 85 to somewhere here 97. We have to calculate these two areas. And in the fourth one, 64 to 76. So we know that 64 somewhere here falls here and 76 fall here. If we consider this area, this area is an interested area, we can come to know the z-score of each values. So I just show you how to plot given data in the normal curve, and now I will solve each x value individually. So here we are given that our mu is 80 and standard deviation is 5. So if x follows normal distribution, so which means x mu will be 80 and standard deviation will be variance, that is 25. To calculate z-score, we will go through the standard normal variate. If you want to go through the standard normal variate, it must for x follows normal distribution. So this is a case we know that x is follows normal distribution, which means mu, here it is a mu and variance. Then our standard number variant is given by z is equal to x minus mu divided by standard deviation. By x following normal distribution, we have taken our formula as a standard normal distribution formula. So now let us consider one by one. So firstly, our example is probability of x greater than 95, which means sample mean is 95. Consider x is equal to 95. We know that formula that z is equal to x minus mu divided by standard deviation. So if we apply to that formula, our x is 95 and standard deviation is 5 in this case, and mu is 80 in this case. I have directly applied to the formula here. So we have to consider x is 95. So 95 minus 80 divided by 5. And when we simplify this, the next stage will be 95 minus 80 will be 15 and 5 carry the same. And still when we simplify this, our z value is 3. For sample mean 95, our z value will be 3 as per the standard normal variant. Now we want to plot this x value and standard value, z value to the standard normal curve, and we want to shade our interested area in the normal curve. So here x is greater than 95, which means which will fall here 95, and x is greater than 95. Since it is greater than 95, I have shaded the area beyond 95. Look at here, I have shaded this part. This part is our interested area. For this part, we need to find out z score and z value. Then let us plot the x value and respected z value also. So as I told you already, x is equal to 80, which means mu is equal to 80. And in this problem, our interested area is x is greater than 95. So our x 95 will fall here. This is a 95. Beyond this, whatever the area it is our interested area, and we have to shade the interested area in the normal curve. This is very important. Shading interested area. Firstly, in the normal curve, we have to find out interested area. Interested area will be based on the given problem. For example, in the A example, x is greater than 95, which means our interested area will fall after 95. And now we have to calculate the z value. So for this, as I told you already, z value for mu a will be 0, because to the left and to the right the will same value, and the center point will be 0. So here z is equal to 0, and we have to find the values for x greater than 95. And for x greater than 95, our z value is 3. And we know how we obtained this z is equal to 3 by applying to the formula. Given details applying to the formula, we obtained z is equal to 3. Since we are dealing with probability distribution, in that too normal probability distribution. In normal probability distribution, we have to get the values in probability. So we know that probability scale starts from 0 to 1. It is never negative. For that, we must look into the table of our interest. To look into the table, we have to prepare data. So we know that our x is greater than 95. We dealt with x is greater than 95, and we found the value z is 3, which means z is greater than 3. Probability of z is greater than 3. And when we simplify this further, so that is 0.5 minus probability of 0 lesser than z lesser than 3. You may ask me how we obtain these values. I have explained it very deeply when I was talking about the first video on normal distribution in properties of normal distribution. The whole area, this whole area is probability is equal to 1, and half of the area is probability 0.5. Half of the area probability 0.5. which is right side is also 0.5 and left side too also 0.5. Since I am dealing in right side only, the value x is greater than 95 falls in right side, and which does not touch to the left side. I have considered whole right side area, that's 0.5. Whole right side area I have considered. But it is not our interested area. Our value x is greater than 95 is falling in right side area. The whole right side area is 0.5 that I have taken here. Now from this 0.5 we have to subtract the unshaded area, which means our uninterested area we have to subtract. Then our shaded area or our interested area Z value we will obtain. For that I have prepared data that probability of 0. Why I have taken 0 here is normal curve is symmetric about the line Z is equal to 0. Here it is a symmetric about the line Z is equal to 0. So I have taken Z 0 here and lesser than 0 Z, and our Z value for x 95 greater than 95 is 3. So probability of 0 lesser than Z lesser than 3. We have to look this value, that Z value 3 in the table, then we will come to know our interested area probability. So let us look into the table. In the table we have two types of table. One is lower side table and upper tail table. In the lower tail table we will get negative values, and in upper tail table we will get positive values. But whatever upper tail or lower tail, except it is negative, the value will remain same, because the upper tail area is also minus 0.5, and lower tail which is also 0.5, which is minus 0.5, upper tail is plus 0.5. So I use upper tail area to know the probability curve of normal distribution. For that I have prepared my data to upper tail entries mode, that is probability of 0 lesser than Z lesser than Z. So we are looking in the upper tail area. Now our Z value is 3. We have to concentrate in this column, Z column. So this row goes for extreme level for Z. For example, if I want to look into the Z value for 0.1, I can go for this 0. If I want to look into the value for Z 0.11, I have to go for this value I have to go for. In the same way, if I want to look into the values for Z 1.40, I have to go for this 0.4192, and if I want to look into the value for Z 1.41, I have to go for this value. This is how this table want to read as. Now our Z value is 3, so I will go down. Since our Z value is 3, I have to look into the Z value of 3 only. So 3.0, this is a 0, first value is 0. So our Z value, Z score for the Z value 3 is 0.4987. Now I have to subtract this value from the half side area of the probability. Then I will get an interested area. So let us subtract the value from our right side area. When we subtract that value, half side value is 0.5, and I am going to subtract the uninterested area, the unshaded value is 0.4987. This 0.4987 is stable value. So I have taken, we have got Z score is 0.0013 for our interested area, and for x is greater than 95, Z score is 0.0013. Here I have subtracted the table value from 0.5 because x greater than 95 purely falls into the one side of the distribution, which means upper tail distribution, and it is different in different cases. I will show in another cases, but totally this is how we will obtain Z values, and for that Z value we have to prepare data to plot for Z table, and from Z table we obtained Z score. This is how we have to read the table. We have to perform that standard normal variate, and we have to locate the data Z value into the normal curve. Now let us look into the another example here. Our second example is probability of x lesser than 72, which means we have to consider x is equals to 72. So in the sense it will falls left side or lower tail of the region, because our population mu is 80. Now let us calculate Z value for this. So I have replaced all the values. X is 72 and mu is 80, and standard deviation is 5. When we simplify this, 72 minus 80, positive value is higher, so minus 8 divided by 5. When we simplify this, our Z value is minus 1.6. So now we have to plot this Z value in the table, and we have to shade our interested area in the normal curve. Later we will obtain Z score for our interested area. Since our Z value is minus 1.6 and we can plot all the values here, and we know that x is equal to 80 and value of Z for x is equal to 0 only because it's symmetric about its mean. And we have to plot the second x value, that's x is equal to 72. So our value 72 will fall somewhere here, somewhere in this shaded area will fall our value 72, and Z value for this 72 is minus 1.6 that we calculated using standard normal variate formula. And now we have to look this 1.6 Z value in the Z table. Then we follow the necessary treatment and then we obtain Z score for our interested area. Here very importantly we should keep in your mind that I have shaded to the left side of the region, which means I have shaded in the lower tile because my scenario is x is lesser than 72 and this 72 is lesser than our population mu. Our population mu is 80 and this 72 will fall somewhere here. Since our case is x is 72, I have to shade the area which is less than the area of 72. So I have shaded all the values which is lesser than 72, which means our Z score will fall in the lesser than 72. So now let us prepare the data for plotting into the table. So as we know, our probability of x is lesser than 72 and our Z value is minus 1.6. we obtained by applying all the details into the standard normal variate. And since I am going to look in the upper tail table, I have removed this minus symbol, so it becomes Z is lesser than 1.6. And now I have to consider the reason that I am going to calculate for. Our value x is lesser than 72 will fall in the left side of the normal curve, which is not touching right side of the normal curve. So our interested area purely going to fall in the 0.5 only when one side is symmetrical to the other side, which will give mirror image. So our x value lesser than 72 falling in the left side of the region. So I have to consider 0.5. And 0.5 is not our whole interested area. Our interested area is different. Our interested area is this shaded value and this unshaded value is not our interested area. We have to subtract unshaded area from this whole 0.5 area. For that I have to look the value of Z 1.6 in the Z table. Then let us look into the table so that we can find out our Z score. Our Z value is 1.6. I will plot 1.6 in the table. So our Z value is purely 1.6, not 1.6123 like that. So I have to look in the 1.60. So our value Z score for 1.6 is 0.4452. Now I have to subtract this 0.4452 from 0.5. Then I will get our whole interested area. So our interested area, if I want to get 0.5 minus 0.4452, 0.4452 is a table value. So when I subtract that value, I got our interested area is 0.0548. This 0.0548 is purely shaded area. So for x lesser than 72, Z score will be 0.0548. Now let us look into the another examples for the consideration under this problem. This example is quite different than earlier examples. In the earlier example, we looked into the only one side or one tail of the region. Here we will look into the two tail of the region. Here we are having our interested area will fall between the 60.5 to 90. So x 60.5, x 90. Between this area we will find. So I have to consider x is equal to 60.5 and x is equal to 90. So I will calculate Z value for each data. Then I will obtain Z score at the final. So as usually for Z standard normal variate, I have replaced the values that 60.5 minus 80, 80 is our mu and 5. So when we simplify this value, 60.5 minus 80, 9 minus 90.5 divided by 5. And our Z value would be Z is equal to minus 3.9. So this is a Z value for 60 x 60 lesser than 60.5, and we have to consider one more example that x is equal to 90. 90 minus 80 divided by 5. When we simplify this, 10 by 5. So our Z value for x is equal to 90 is Z value 2. Now we have to plot this data in the table, in the curve, normal curve. So the whole shaded area is our interested area in this problem. As we know, x is equal to 80 and Z value for that x is 0. And we know that our interested area will fall between the 90 and 65. For 90 we have calculated the value, Z value is 2, and for 60.5 x is equal to 60.5, our Z value would be minus 3.9. Here purely I have shaded the region between 60.5 to 90, and finally we have to look into the Z score. For that I need to prepare the data to plot these Z values into the Z table. So we know that probability of 60.5 lesser than x lesser than 90, which is given in the problem itself. When we replace this x value by our Z value for 60.5 is minus 3.9. Here we obtained that, and Z value for 90 is 2. Here we obtained that. And further step would be for this probability of minus 3.9 lesser than x lesser than 0. Here again I am going to tell you why I am taken 0 is our normal curve. Here it is our normal curve is symmetrical about this line 0. It is symmetrical, so I have to consider this 0 here, and plus probability of 0 lesser than z lesser than 2. 2 is z value for x 90. Here one more thing you should keep in your mind. By this equation you may come to know I'm going to add the value z score of minus 3.9 z value and 2 z value, because in the normal curve my interested area is covered both sides of the upper tail and lower tail of the normal curve. In my earlier example, one was at right tail, one was at left tail, but here it is falling in the both side. Since it is falling both side, I have to add the values of both value. So I am going to add the values of z value score of minus 3.9 and z value score of 2. So when we simplify this further to plot into the Z table, probability of 0 lesser than x lesser than 3.5, I have removed negativity because I am going to look in the upper tail of the table. So plus 0, probability of 0 lesser than z lesser than 2 remains same because there is no negativity in this positive value. So then we have to see the Z score for 3.9 and Z score for 2. So in the upper tail of standard normal distribution, I will look into the 2 value. First one is 2. For 2 Z square is 0.4772, and one more Z value I have to look at here. Z 3.9. For Z 3.9, our Z score is 0.5000, and in the Z table highest value is 3.9 only. So let us take these 2 values and perform our calculation. Here I have considered both table value of Z value, table score of Z value 3.9 and 2. For 3.9 our Z score is 0.5, and for 2 our Z score is 0.4772. When we add both together, our interested area, our Z score for x between 60.5 to 90 is 0.9772. So you may come to know the whole shaded area is our interested area. We calculated in this way. Then without delay, let us see one more example in this problem so that we can become very clear about the problem. Here it is also between probability between x 85 to 97, but the shade area will be the different than earlier example. Here we have to consider x is 85 and x is 97. Let us take a first example 85 minus 80 and 5. I have simplified this further, so z is equal to 1. Now I will consider second x value, that is 97. 97 minus 80 by 5, so our z value would be z is equal to 3.4. Now we have to plot this data in the normal curve. So again I'm telling you, the shaded area is our interested area. There we have to look our z score. And one more thing we have to keep in our mind, that our 2x value is falling in the right tail of the normal curve. So even though this is a between case, but the treatment for the z score calculation will be different here. That's why I have considered this type of problem under this. Then let us plot the respective values for these two. For x is equal to 80, our z value will be 0. And we know that our x is equal to 85. This starting point is 85 and z score, the z value for 85 is 1. We know that we have calculated here z is equal to 1. So our for x 85 z value is 1. And for another value x is equal to 97. For 97 our value of z is 3.4, that we have calculated here 3.4. Now let us prepare the equation to plot into the table. We know that we have a situation called probability of x between 85 to 97. So we will replace 85 by z value, that 1, and 97 by z value 3.4. When we go some further, our next calculation would be probability of x is 0 lesser than z lesser than 3.4. You know that it is a symmetric about mean, z is symmetric about mean, that's why I have considered 0 again. And 3.4 is the z value of 97, and minus probability of 0 lesser than z and lesser than 1 is z value of 87. And again you may be thinking, why I am going to subtract these two values. Normally in such a cases we have to subtract highest value from the lowest value. In earlier example, our interested area fall between two regions, that is minus infinity and positive infinity. But in this example, our interested area is falling right side, which means upper tail of the region. In this example, we will give two treatment for calculating z score. One is find the value z score for 3.4 and find the value for 1 and subtract highest value from the lowest value from the highest value. Then you will obtain your z score or your interested area score. Otherwise, you may do one more thing. You can calculate a z score for 3.4 and subtract this value from 0.5 because it lies in the one side upper side, and again find the z score for 1 and subtract from 0.5. Then the value of 3.4, so after subtracting from 0.5 and value of 1 after subtracting from 0.5 add together, then also you will get the same value. And it is a easy way to calculate between type when both x value fall in one tail of the region. Now let us simplify further to plot in the z table. Now we can directly look into the z table because both values are in the positive side. So for z 3.4 and 1, our z value would be for 3.4 0.4997 and for 1 our z value would be 0.3413. Now we have to subtract 0.3413 from our highest z score 0.4997. So when we subtract both table value, our interested area we got that is a z score. Z score for our interested area is 0.1584. In the whole probability area 1, our interested area for between 85 to 97x is 0.1584. This is a shaded area. Now let us see the last example in this problem is x between 64 to 76. Now I have to consider x is equal to 64 and x is equal to 76. I will calculate for first x is equal to 64. 64 minus 80 would be minus 16 by 5. Then z value would be minus 3.2. Now I will consider second value, that 76 minus 80 by 5. So z value would be minus 0.8. Now let us plot these two values in the table, and very importantly between value of x 64 and 76 lies in the left side, which means lower tile. When we plot the data for these given values, x is equal to 80 and their respected z score is 0, since it is symmetric about its mean, and our second value is 76, x is equal to 76, and that z score z value we found that minus 0.8, and our one more x value is 64, and that z value also we found that minus 3.2. And here I have shaded my interested area. My interested area will fall between 64 here. This shaded area is 64 to 76. My interested area is this. Now I have to look z score for z values of these two z value and do some necessary requirements. For that I will prepare an equation for that. So we know that the probability of x between 64 to 76, and I have replaced z values for x. For x 64 our z value is minus 3.2. For x 76 our z value is minus 0.8. And when we simplify further, p of 0.8 lesser than z lesser than 3.2, I have removed negativity in the z values in the both sides, and we know that 0 is symmetric about its mean in the both sides, so I have taken 0. And one more very important consideration here is I'm going to subtract the z score obtained from 3.2 to 0.8, because x value 64 and 76 both are falling in the lower tail of the normal curve, which means which are falling in one tail. So we have to subtract one from another, or else we can also calculate each value individually by subtracting 0.5 by the value of z score of 3.2 and 0.5 from the value of z score of 0.8. Later both remaining value we can add together, whereas here I will directly subtract from the value of 3.2 and 0.8. For that let us see the table, z table. Our first value is 3.2. For 3.2 we have 0.4993, and for 0.8 we have 0.2881. Now let us subtract 0.2881 from the value of 0.4997. So when we subtract table value of both z value, we obtain our z score. Our z score for x between 64 to 76 is 0.2112, and this z score is shaded area in the normal curve. I hope you got a thorough understanding over how to calculate areas in the normal distribution using normal curve and z table. If you have any doubts regarding normal distribution and area or properties, please do comment in the comment box, and I am ready to answer to your queries. Thank you so much for watching. Please do subscribe to my Vision Academy YouTube channel.